会议呢，基本上是一个科学的会议，是一个有关科学发生的历史。
Signal transduction and active evaders of transcription.
Yeah.
STA.
I hope I can see the slides. I'm going to have to ask you to change them for me, please.
We published the first analysis.
So I'll do my best to give my talk remotely in California.
And mechanisms of signaling and physiological fine tuning.
Virus and receptor discovery and development of vaccine antibody.
而这个交往更多的是在胁迫感染这种情况下发生的一个死亡。
And physiological. I will point out key persons as I go through the talk. I'm going to overview IL-2 and common gamma chain family cytokines and mechanisms of signaling and physiological fine-tuning, and then talk about fine-tuning via the STAT5-dependent IL-2 alpha superenhancer and IL-2 partial agonist in autoimmunity and with relevance to autoimmunity and anti-tumor immunity. And then for the final segment, talk about IL-21 versus IL-2 and recent data that LMO4 can promote IL-21 STAT3 signaling, T-cell stemness, and anti-tumor immunity. So here's the common gamma chain family comprising IL-2, 4, 7, 9, 15, and 21. They all share the common gamma chain, which is mutated in humans with X-linked SCID. This is a profound disease with greatly diminished T and NK cells and non-functional B cells. It's caused by, as we showed many years ago, in the IL-2 receptor gamma chain, the common gamma chain, and it inactivates signaling by all of the cytokines with defects in IL-7 and IL-15, explaining the defects related to T and NK cell development, and in IL-21 to explain the non-functional B cells. Thus, it's a disease of defective cytokine signaling, and we demonstrated, as did a couple of other labs, that JAK3 could associate with the gamma chain, and that led, not surprisingly, to the finding that JAK3 deficient SCID phenocopies X-SCID, as was shown in Nature by the lab of Gigi Notarangelo and by my own lab in Science with help from Rebecca Buckley and John O'Shea. We predicted agents that inactivate JAK3 function may be potent immunosuppressants, and that helped spawn the evolution of the quest to make JAK inhibitors with tofacitinib, approved by the FDA in 2012, but a class of JAK inhibitors with currently 13 of them in clinical use for a range of diseases, including autoimmune disease, atopic dermatitis, alopecia areata, myeloproliferative disease, and also COVID-19. IL-2 was the first gamma-C cytokine discovered by Bob Gallo's group in 1976 as a T-cell growth factor, but quickly recognized pleiotropic. And for our purpose today, the actions on effector T cells and Tregs are what we care about, with manipulating IL-2 having implications for cancer and autoimmune disease. There are three classes of IL-2 receptors binding IL-2 with low, intermediate, or high affinity. The intermediate and high affinity forms are functional, with intermediate affinity on NK and CD8 T cells, and high affinity on activated lymphocytes, Tregs, ILC2 cells. Heterodimerization of the beta and gamma cytoplasmic domains is required for signaling. And cytokine immunotherapy, rather broadly, and certainly relevant to IL-2, is premised on either augmenting or blocking cytokine activity, or selectively augmenting or specific action, for example, T effector versus Tregs. There are many approaches that are being used, including using natural cytokines, and pretty much all of these are relevant to IL-2, or modified cytokines such as pegylation, monoclonal antibodies to cytokines or their receptors. And there are many monoclonal antibodies to type 1 cytokines that are clinically approved, targeting signaling pathways, and I showed you, of course, JAK inhibitors, and then a range of combination or engineering approaches, such as antibody-cytokine complexes, or fusions, or receptor cytokine fusions, surrogate cytokine agonists, orthogonal cytokines as pioneered by, of course, Garcia, neokines or mimics, worked on by David Baker, where we've had the good fortune to contribute studies related to Neo4 and Neo-IL-21. And what I'm going to focus on today are engineered muteins and targeting gene expression, and initially starting with the latter. But before I get to that, I want to go over pathways of signaling and fine-tuning. IL-2 signals via 3 major pathways: RAS-MAP kinase, PI3 kinase AKT, and JAK-STAT. And the basic ways of modulating and fine-tuning are using differential stats, for example, STAT5 versus STAT3, using STAT5 dimers versus tetramers, the regulation of super enhancers, metabolic effects, and cytokine partial agonists and antagonists. So we're going to begin with the IL-2 alpha super enhancer, which is a positive feedback way of regulating the IL-2 pathway. So these studies were done primarily by Roseanne Spolsky and Peng Li in my lab. Peng now has moved on to Amgen, and it was an important collaboration with Ellen Rosenberg's group, Chris Nagau's group, and the Vijay Anand laboratory. CD25 expression is tightly regulated with constitutive expression on DN2 and DN3 cells in the thymus and on peripheral Treg cells. And in addition, the gene is highly inducible on effector cells and NK cells, among others. We looked a number of years ago at ranking super enhancers based on the density of binding of STAT5, and in both CD4 and CD8 cells, the highest ranked super enhancer was IL-2R alpha, a positive regulator, followed by CISH, a negative regulator. Super enhancers in general are much larger than typical enhancers. They have high mediator binding, and they are typically regulating lineage-specific and highly inducible genes, such as IL-2R alpha. In this gene, you can see that there's extensive STAT5 binding by ChIP-seq, spanning the transcription start site in an area of high K27 acetylation. This is in the mouse, but the general properties are in the human. In order to functionally interrogate the super enhancer and elucidate to what extent elements were redundant, additive, or cooperative, we used CRISPR-Cas, and we generated a large number of different mutants in vivo in mice. When we deleted the intronic region, you can see with TCR stimulation of CD8 cells followed by IL-2, there was essentially an abrogation of the induction of IL-2 alpha that was seen in the wild type. With the upstream deletion, you can see that the expression is lower, but it's still quite robust. Conversely, with deletion of the upstream region, there was a loss of CD25 expression on DN2 and DN3 cells in the thymus. The cells are still there, but they just don't express CD25. Whereas deletion of the intronic region allowed essentially normal expression on those cells. The upstream region, when deleted, also resulted in a substantial decrease in CD25 expression on thymic and splenic Tregs. And the function of these Tregs, their suppressive function, was substantially attenuated. Well, when we really looked in vivo at the animals, we found that with the upstream deletion where the Treg development expression of CD25 and suppressive activity is defective, there was the development of autoimmune alopecia occurring in approximately 30% of both males and females with onset at 10 to 12 weeks of age, whereas the intron deletion had no effect. Looking by immunohistochemistry, you can see CD8 T cell infiltration into the hair follicle regions in the skin. Overall, however, this is less inflammatory than what is seen in human alopecia areata. So we looked further by single-cell RNA-seq, and what we observed is that there, of course, were multiple populations that could be identified, but looking at the Tregs with IL-2 alpha expression in the upstream deleted animals, whether or not they had alopecia, there was defective expression of IL-2 alpha. But the animals with alopecia, or I should say the cells from the animals with alopecia, had much higher levels of upregulated and downregulated genes than did cells from animals that did not have alopecia. So what we know then is that the upstream superenhancer region is critical for Treg function, but how do the upstream and intronic regions contribute to chromosomal looping and CD25 expression? And to look at this, we used high chip analysis, where you can see, looking in the wild type with IL-2, there is very extensive looping from both upstream and intronic regions to the transcription start site. And of course, the wild type has high-level IL-2 alpha expression. With deletion of the upstream region, we, as would be expected, lose all the looping from within that region to the promoter, but the intronic looping to the promoter is very similar to what's seen in the wild type, and there is retention of fairly good IL-2 alpha expression. However, with intronic deletion, there's the loss of all looping from that region, but there also is marked attenuation compared to the wild type of looping upstream to the promoter, and this is associated overall with a substantial loss of IL-2 alpha expression. Therefore, we know that the intronic region controls CD25 expression in effector T cells. The upstream region controls expression in double negative thymocytes and Tregs. And the ultimate goal, as one goal, it would be interesting to selectively target superenhancer elements to potentially, even therapeutically, fine-tune CD25 expression in Tregs versus effector cells. Well, let's come back to our model of fine-tuning and next talk about IL-2 partial agonists and antagonists. And these studies were a major collaboration primarily with Chris Garcia's laboratory, with help from a range of other laboratories. In my lab, the work was done primarily by Suman Mitra and Fei Mo, with a lot of help from Peng Li. The first study was in 2015, and the second in 2021. And in the first study, what we did was it was premised on super IL-2, which was made by Chris Garcia's laboratory, where they reported a molecule that had very strong binding to IL-2 beta and elevated activity in terms of stimulation, where it did not depend on the presence of the alpha chain. And in the 2015 study, what we did with Chris was to interrogate the effect of 4 amino acid changes at the IL-2 gamma-C interface, which resulted in lower affinity for the gamma chain, blocking heterodimerization. And this is a potent inhibitor, blocking IL-2 to STAT5 and IL-2 alpha expression, blocking NK cytolytic activity in response to IL-2 and IL-15, as well as blocking the proliferation ex vivo of cells from patients with a chronic smoldering form of H2V1-induced adult T-cell leukemia. Therefore, we had super IL-2 and also a potent inhibitor. But what about molecules with intermediate activity? Might these be partial agonists with cell type or signaling-specific activities? And so we looked at one of these, H9T, with a single amino acid change at the IL-2 gamma-C interface. It had normal phosphorylation of ERK, but you can see it had greatly attenuated phosphorylation of STAT5, even at very high concentrations, indicating that it has a lower Emax and it is a true partial agonist. So we wondered, did it induce a distinctive gene expression profile? And it does, and these are looking at CD8 cells cultured for 6 days with, at the far right, H9T giving markedly lower expression of genes encoding TIM3, CD4, etc. So checkpoint inhibitors, lower expression of genes encoding cytolytic molecules, but higher expression is TXCR3 and 6, and of TCF7, providing more of a memory or T stem cell-like memory phenotype, prompting the question whether it would be more effective in adoptive transfer immunotherapy. And so what we did was to use B16 melanoma and the PMEL1 system, where animals were implanted with melanoma, and then PMEL1 cells were cultured in vitro with IL-9, super IL-2, or H9T, and then adoptively transferred into the animals. What you can see is that the H9T molecule was very effective, and this was associated with greater survival and tumor-free period, and indeed this is also true in a CAR-T model. Therefore, we had RETR as a potent antagonist, H9T as a partial agonist, promoting a T stem cell-like phenotype. The level of STAT5 activation is important, and there's the possibility of engineering a range of molecules with translational potential. And the work is early. I'm just going to show you a couple of slides on one of the molecules that we're just calling for the moment IO2X1, where you can see that it induces lower expression of CD69 in blue, CD25, and CD39, but higher expression of TCF1. It works well in both mouse and human cells, and it also is associated with lower expression of checkpoint inhibitors like LAG3, TIM3, and 2B4, with enhanced anti-tumor efficacy in the B16 melanoma model, with better survival and greater tumor-free efficacy. So let's return again to the cartoon. And for the final segment, I want to talk about metabolic effects and comparing IL-21 versus IL-2. So these studies started a 2020 paper that was done by Dalton Hermans with equal contributions by Sanjivan Gautam in Luca Gadinone's, lab, then in the NCI, but now in Regensburg. And we built on much earlier studies that we've done together with Nick Restifo, demonstrating that IL-21 is more effective than is IL-2 in adoptive transfer immunotherapy. IL-2 is much more metabolic than IL. On the left, don't worry about reading anything, but you can just see from the heat map how much more energetic it is in the overall metabolic profile. And on the right, you can see the higher induction of lactate, whereas IL-21 does not significantly induce lactate. We wondered, therefore, what would be the effect of inhibiting LDH, and to this end, we used a small molecule reversible inhibitor of LDH developed by Len Necker's lab in the NCI. When we looked at its effect on IL-2, here by RNA-seq, you can see that it substantially blocked the gene induction profile, including of a number of transcription factors such as the NR4A family of exhaustion markers. But it also had significant effects related to IL-21, despite the fact that there was minimal increased production of LDH. And so here you can see the lower expression of a number of genes encoding cell surface proteins, which are checkpoint inhibitors or associated with exhaustion. We wondered, will inhibiting LDH improve anti-tumor efficacy? Here again, we used the PMEL system, and we recapitulated the earlier findings that IL-21 is better than IL-2, but the addition of the inhibitor improved both the anti-tumor efficacy of IL-2 and of IL-21, with the one plus the inhibitor being the best. And so we think what is happening is that IL-21 via the activation of STAT3 promotes fatty acid oxidation, resulting in more of a memory T cell phenotype, whereas IL-2 via STAT5 is promoting glycolysis and more of an effector T cell phenotype. But with the inhibition of LDH, both of the cytokines are now moving even more so towards a memory response with the greatest anti-tumor efficacy with IL-21 LDH inhibitor. And so one of the key questions is, what is the mechanism underlying the synergy between IL-21 and LDH inhibitor? And this is work of Roland Schelker, who began in Luca's lab in the NCI, then he joined Luca's lab a couple of years later in Regensburg. So what I'm going to tell you is about LMO4 as a driver of anti-tumor immunity. We had observed that the combination of IL-21 plus the LDH inhibitor was synergistic for inducing gene expression of LMO4, which is, of course, a limb domain-only family protein. These are transcriptional co-regulators affecting cell fate growth and differentiation, and LMO4 is the only member expressed in post-thymic T cells, but the expression is quite low. Considering CD8 T cell differentiation, the cells that we really want for good anti-tumor efficacy are the T stem cell-like cells in the self-renewing compartment. Looking at expression of RNA, you can see that LMO4 indeed is very poorly expressed in CD8 T cells. We also noted by mining data from a CRISPR screen performed by Alex Marson's laboratory that LMO4 mapped together with MYB, BOT2, and IKZF1, which are regulators of stemness, and opposing to factors like TBX21 and IR4, which promote effector differentiation. In addition, we also observed that TWS119, which is an inhibitor of GSK3 beta, increased expression of LMO4. So this inhibitor mimics Wnt signaling and increases beta-catenin, upregulating TCF7 and LEF1 and promoting human and mouse SCM cell development. And so these data altogether suggested to us that LMO4 would itself be a promoter of T SCM cells. And so we looked at PMEL1 cells expressing LMO4 or not expressing LMO4, introduced these into animals, and then vaccinated the animals with the melanoma antigen GP100, and then looked at days 5 or 30 in the recall response. The recall response by revaccinating with GP100. And what you can see is that in the recall response, there is an expansion of CD8 T cells, and these cells are more of a stem-like phenotype, being CD62L positive, KLRG1 negative, and moreover they exhibit polyfunctionality with production of more than one cytokine. Well, what about anti-tumor efficacy? So you can see here that the PMEL1 cells expressing LMO4, when introduced into animals that had been implanted with B16 melanoma, had much greater anti-tumor efficacy as well as prolonged survival. And I'm not showing the data, but they also worked, although albeit not as robustly, in a humanized CD19 CAR T system for acute lymphocytic leukemia in NXG mice. Interestingly, LMO4 overexpression promotes CD8 T stemness with expression of a number of genes associated with the stemness signature. It also augments the ability of IL-21 to induce TCF7, ZFP36, and SOX3, which again go with the T stem cell-like phenotype, and it also promotes STAT3 target genes. And what we show is that LMO4 physically can associate with JAK1, and it augments IL-21-induced phosphorylation of STAT3. So in summary, what I've shown you is that LMO4 promotes a T stem cell-like phenotype, helping to explain the cooperative effect of IL-21 plus the LDH inhibitor. If therapeutically useful, it may be important to incorporate a suicide mechanism to eliminate adoptively transferred cells, given their ability to expand. And overall, I've discussed the therapeutic potential of manipulating the IL-alpha superenhancer, of cytokine engineering, and a synthetic biology approach of introducing LMO4 expression. So I just want to again highlight multiple ways for controlling and fine-tuning cytokine signaling, and to close with a list of all the many individuals who contributed to all this work. So thank you for your attention, and I'm happy to answer some questions.
就是现在呢，我们要成立这样的一个研发联盟，这个也是为下次会议做准备的。